All right, in my second last video of 2015, I think, we're going to whip through coming up with the equations of of trig functions or trig graphs leading us to trig function equations. So let's look at these points here. We're going by 45, so it goes space 45, space 90, space 135, space 180. And same here, minus 45, oh, I messed up, minus 45, minus 90, and then we'll just use our regular scale here. So that's 8 here, 6 here, the 0.04 is here. So I'm down to my minimum. I better be bouncing back up here, I think. 45, I get back up to 6, good. And then 90 is 8, down to 4. It is a sine curve, so don't just connect these. Okay, we have tops, and we have bottoms, and then we have this guy here is half a bottom, this guy here is half a top. So that's what that looks like. And we have to come up with an equation with this. Okay, so it doesn't matter if we do sine curve or cos curve. Just remember this. Sine curve does this, cos curve does this, and it won't matter until later. We're going to go with our sine curve first, and then we'll transform it to a cos curve after. So we're going to find A, K, and D, and C. Probably, maybe not the best way, the best order to go in, but we'll just keep it in this order because that's what we've dealt with this. Okay, so you end up with AKDC, and we'll show what the general equation looks like and then plug in the numbers at the end. So A is your amplitude. So I look at this curve here. Here's the middle of the curve like this. So I look at it right here. I can tell that my amplitude is 2. So my A is going to equal 2. Another way to get it is max minus min divide by 2. So in this case, it'd be 8 minus, that's my max. My minimum was 4 divided by 2, which is 2 either way. No matter how I do it, A is 2. Okay, then I get my K. K is going to be, before I said that 360 divided by my period is equal to K, but you can swap these out and say that 360 divided by K is my, no, let's go back. Before I said 360 divided by K is equal to my period, and now you could say that 360 divided by period is equal to K if you're looking for K. So swap these out here, like I said. So my period you get off the graph. What's the period of this graph here? It doesn't matter where you start. Just make sure, it gets a little tricky. Make sure you do a full cycle. So if I started here, it's 90 degrees to get down here. And then where do I end up back at the top? Right here. So 90 more. So 90 plus 90 is 180. Let's just confirm that. If I started here at the bottom, I get back at the bottom 180 later. So either way, my period is going to be 180. So in this case, it's 360 divided by 180, and my K is also 2. So A is 2 and K is 2. D is my shift. Now, this is important to figure out what you're looking for, a sine curve or a cos curve. And the only difference between a sine curve and a cos curve, the magnitude is the same, the period is the same, the vertical translation is the same, how much I moved up or down is the same. The only difference is where have I started? Where am I starting here? And look at this curve here. That's a sine curve. A sine curve starts at the rest position and goes up. Where am I here at the rest position going up? Well, there's rest position, but I'm going down. Here. Here I'm at the rest position. I'm going up. Okay. So that is a sine curve right here. And then I would continue like this and finish my sine curve. Where does that happen? That happens at D equal to 45. Now, I know that you might be thinking to yourself, that's negative. It's not negative. It's positive here, but in the formula, you'll see in a second, it'll then change to negative in the formula. The last thing is C, and that is the vertical translation. And when you look at this, don't look at the max and the min, okay? Because what we've done, we've already stretched this. So we've stretched it from its normal place, but then we take the entire graph and we move it. So look at what's happened to the rest position. Where is the rest position? And this rest position here is at 6. So I moved up 6, so my C is equal to 6. Very simple, okay? Where is my new rest position? Normally, or sorry, the general equation of a trigonometric function that has been transformed or translated is this: A, K, D, C, and then what happens is usually we have sine or cos here, and then we have K, and then it's theta minus D plus C. So A times sine or cos, K bracket theta minus D, remember the bracket, plus all C, all plus C. So let's look at this and sub right in. And that is going to be just from what we found here. A is 2, so there goes 2. We said it's a sine function. So we have sine. K was also 2, just a coincidence. Theta minus 45. That's where you get the minus 45. This is right 45. You guys are used to that now. This is positive 45, the negatives part of the equation, and then C is 6. So I take it and I move it up 6. Is that right? It is, and you can throw it into decimals later to figure out if it is correct. The other thing now, if I said, hey, okay, that's great. Now find a cos curve. The cos curve is going to be the same amplitude. It's going to be the same period. The only difference is this part here. So let me just finish off here. And then you ask yourself this: where does my cos curve start? How much do I have to move to get my cos curve? My cos curve starts up top and goes down. So where am I up top and going down? I'm here. I'm up top and going down. Also here. So let's just use this one here. This is minus 90. So I'm left 90. So I'd be plus 90 here. But let's say I started this one here. And I wanted to start the curve here and say that I move to the right 90. So if I move to the right 90, I'm also minus 90 away. So I could have had the same curve here with minus 90. Now, if you say, well, hold on a second, how come I can I can have more than one answer? Well, you got to think, right? These curves repeat each other. And how often, when do they repeat each other? They repeat each other when they're done a cycle. And what's the length of a cycle? The length of the cycle is a period. And so they should be a period apart from each other. And let's think about this for a second. We said that the period of this guy is 180. We already went through that and said that that's what happens. It takes 180 degrees to go from start to finish. Start to finish 180 degrees. So look at this guy here. This is left 90. This is right 90. So here's my axis. One's over here 90. One's over here 90. They're 180 apart from each other. They're one period apart. And that makes sense because look, I keep repeating myself every period. Okay? That sounds like what I say when I'm teaching. Get it? Repeat myself. Anyway, so that's that. Okay, they're one period apart. And now what about these two guys? How does a sine relate to a cos? A cos and a sine are 1/4 of the period apart. Here is where a sine starts. Here is where a cos starts. A cos starts there, a sine starts there. So here I have minus 45. Here I have minus 90. They're 45 away from each other. Think about a period is 180. A quarter of a period, half it's 90. A quarter is 45. They are 45 degrees away from each other. And that's it. Okay, you come up with your equations like that. If you want to try some more of that stuff, just A, K, D, C. Is this right? Throw this into Desmos. See if you come up with these key points. I think you will. Okay, I hope you will. Otherwise, I made a mistake. Okay, good luck. Take care.